Recently, the IAC completed an 18-month study, The Green Road to Space. You will notice that the study was done by a number of qualified authors, most of which were responsible for major chapters of the report. Copies of the complete report are available on the ISCC.org website, iscc.org. One of the main topics, space-based solar power, will be presented by Dr. David Dodson in the session devoted to space-based solar power. The Green Road to Space is the first study done by the ISCC, where it assumed that the space elevator can and will be built using single crystal graphene as the tether material. The main purpose of this study was to see if and in what ways a space elevator could have environmental benefits to the Earth. The results of the study will be presented along with additional ideas of what an existing space elevator system can enable. The envisioned elevator systems or galactic harbors would consist of 6 fully operational space elevators with pairs at 3 different locations around the Earth. The system allows 180,000 metric tons of mass to be delivered to GEO by 2050. 3 major things that we considered in the study were not new ideas, but ones that were dreamed of in the early days of the space program. These are space solar power, nuclear waste disposal, and Earth sun shades at L1. In each of these, we contrasted the use of the space elevator to that of using rockets to accomplish the same end result. The idea of sending nuclear waste off into space is not new. It was basically shelved because of the consequences of a possible rocket failure with nuclear waste aboard. The space elevator eliminates that possibility. Bert Malloy researched all types of nuclear waste, but focused on the spent nuclear fuel and nuclear weapons because of the extremely long half-lives involved. His research looked at all the various current ways it is contained and stored. The main result of this study was found that it is a monumental problem and has had minimal success for safe and long-term storage. This slide shows a breakdown of how much is stored and a projection of how much it will be by the 2050. The important thing to notice is that it may be as much as 810,000 tons by the year 2050. The ideal disposal of high-level nuclear waste would be so that it no longer poses a threat to Earth and our way of life. Currently, the consensus among nuclear nations is for deep geological repositories, DGRs. There are several interesting driving functions that are in play regarding this approach. Some of the waste has to be stored for up to 500,000 years. Therefore, disposal implies it must be extraordinarily unlikely for humans to encounter it accidentally or purposefully, and that no known natural or geologic process will make such exposure possible. The US to date is the only nation to have actually done a significant amount of construction on such a site, Yucca Mountain in Nevada. However, the many delays this project has been started have made the future of Yucca Mountain facility extremely uncertain at best. Finland started planning for a similar project in 1983. Plans to apply for an operating license this year with hopes to begin actual depository operations in 2025. Yes, started planning in 1983 and 42 years later, actual usage may occur. This story is very similar to what other nations have experienced, and thus a new method of storage is highly desirable. With a mature set of 3 galactic harbors and each with 2 tethers, this is possible. As you can see in the chart, 180,000 metric tons is easily achieved by 2050. Thus, the projected nuclear waste could easily be handled. The important thing to note here is that solving the high-level nuclear waste problem would encourage a greater use of nuclear power to meet the future electrical needs of our planet and doing it in a non-polluting and green manner. The second benefit that I will discuss was posed by Dr. Roger Angel, a professor at Arizona University in 2006. He proposed the idea at a National Academy of Science conference in May and received a grant from NASA to pursue the idea that October. He proposed to put a sunshade in space at L1 between the Earth and the Sun. The plan is to make trillions of 2-foot in diameter discs, ultra thin, at about 1 gram each. The total mass needed is about 20 million tons. Again, an enormous amount of rocket launches would be needed to handle it. With galactic harbors at fully operational capacity, we see here that it could actually be done in 11.5 years. The space elevator could do it in a crisis and much cheaper and greener than by other means. Meeting the power needs of the future can be done in various ways, but doing them in non-polluting ways is necessary. With a solution to the high-level nuclear waste problem, more nations could use nuclear power for their future needs. Fusion reactors is another way. The current research is using helium-3 as the primary reactive material, thus avoiding the high-energy neutrons emitted in the deuteron-tritium reaction. Helium-3 can be extracted from seawater, but not easily. Helium-3 is abundant on the surface dust on the moon from solar winds. Solar winds are diverted by Earth's magnetic field, thus not near as much reaches the Earth as reaches the moon. A little robot could collect dust, moon dust, and have it shipped to a separation facility at GEO, and then easily shipped back to the Earth using the galactic harbors. With operational galactic harbors in place, many additional possibilities come to mind. Polluting industries on Earth could be set up at GEO, thus raw material could be set up on climbers and finished products could be returned to the Earth. Since refining is the most polluting industry on Earth, it would be obvious to refine materials collected from mining asteroids at GEO before sending the refined materials back to the Earth. Industries making heavy devices for space could make them at GEO. Materials set up on the elevator, then assembled in the weightless environment of space. Thus, the way in which space-based nuclear power can be used. Scientific experiments for space would no longer be limited to size or mass. And of course, lunar and Mars communities can easily be supplied with needed supplies and equipment on a regular schedule from the space elevator. Is the space elevator itself the polluter? We researched what impact studies addresses and found that very little would pertain to the Earth port, except for human waste handling and other things that oil platforms have dealt with for years. Thus why we claim the space elevator or galactic harbors are the green road to space.